Hey everybody, let's go over section 4.3. We're talking about basic trigonometric functions. You've probably seen this before. I'm going to ask you this first question, so let's look at this one. Can we infer, or can we decide, which of these triangles are similar and what is this angle here? So what do we notice? We notice that every triangle has a 31 degree and every triangle has a right angle. So what do we know about that? We know that all of these triangles are similar. I see a couple of things here. I know that 70 and 35 are exactly half, or 70 is double 35. So that means if I take 21 and I double it, I can get this side over here, which is 42, right? So the thing about that is I know that just like that, with basic trig functions, I can also see that every triangle that has those same angles will have the same ratio. Okay, so a couple of things. The three basic trig functions are, the abbreviation is SIN, but that's for sine. This is cosine, and this is tangent. So even though these are abbreviations, those abbreviations are sine, cosine, tangent, not sin, cos, and tan, okay? Looking at this, if this is our unknown angle theta, remember from the theta, this is our opposite side, always from the opposite from theta. This is our hypotenuse, and the hypotenuse is always the longest side in a right triangle. And this is our adjacent side. Hopefully you've seen that before. And we also probably have learned before that sine is the opposite side over the hypotenuse side. Cosine is the adjacent side over the hypotenuse side. And tangent is the opposite side over the adjacent side. Specifically, if we're looking at our A, B, and C sides, this tells me if this is little a, opposite from that is angle big A. Opposite from side C is angle big C. And opposite from side B is angle big B. So you'll need to remember that as well. And remember that all of sine, cosine, and tangent comes from before. So let's say, for example, here's another unknown angle. We call this alpha. Sometimes angles are not just theta. Sometimes they're alpha, different Greek letters. It's fine. So from here, we always want to make sure that I'm drawing a line from the opposite side from that angle. So this is our opposite side. Our hypotenuse is the longest. And then here's our adjacent. So the sine is, remember, opposite over hypotenuse. So we know that's 5 over 13. Cosine is A over H, which is 12 over 13. And tangent is opposite over adjacent, which is 5 over 12. Try this next one right here. So again, here's my unknown angle. So therefore, this is the opposite side. Where's the hypotenuse? Hopefully you said it was 17 hypotenuse, and here's our adjacent. So from here, how do we look for sine, cosine, and tangent? Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Go ahead and fill those in. Push pause. All right, let's check to see what you got. So you should have gotten opposite over hypotenuse here, adjacent over hypotenuse, and opposite over adjacent. Oopsie, I wrote that wrong. Opposite over adjacent here. Good job. So how do we find the missing side? So here we go. If I'm looking for the missing side here, we're going to set this up. What do we know? Remember, here's our angle. Now, instead of a missing angle, this is our angle that we're given. So from here, this is going to be our opposite side. Here's our hypotenuse. We know that it's the hypotenuse because it's opposite of the right angle. And here's our adjacent. So here's what I know. I want to look for the missing side. So I'm going to circle what I'm looking for. Here's what I'm looking for. I'm looking for the hypotenuse. I'm also going to circle what I know. I don't know the opposite side. I do know the adjacent side. So which of and TOA are dealing with the adjacent and the hypotenuse side? Well, so it deals with the opposite side, which we don't have. Deals with the adjacent and the hypotenuse side. So this is what we're going to set up. So I know that C is cosine of the angle is 28 degrees equals the adjacent side, which is 22, over the hypotenuse side, which is x. So this is my equation. From here, now we're going to solve, okay? Here, I've got x in the denominator. I can't solve x in the denominator, so I'm going to multiply x to both sides. So I've got x times the cosine of 28 equals 22. I'm still needing to get x by itself, so I'm going to divide both sides by this cosine of 28. Now, cosine of 28 is just a number. So we've got x equals 22 over cosine of 28. Go ahead and plug this into your calculator. Let me show you that really quick. Oops. Okay, so if I've got 22 divided by cosine of 28, we also want to make sure that in our mode that we're in degrees. So do you see how you have to hit mode, which is next to the second key? And then I'm going to make sure that degrees is highlighted because that's what we're dealing with. So degrees is there. I know I can quit out of that. So now we're going to go 22 divided by the cosine. So cosine is right here. Right in kind of in the middle of your calculator, it's cosine 2 above the 8 of 28. Hit enter, and we get approximately 24.916, which rounds up to a 7. And we know that it's not an angle, it's just a side, so that's our length. Okay, let's go to this next one. It says find the missing angle. So again, here's our missing angle. We're going to draw an arrow to our opposite side. We're going to label all the sides of our triangle. Circle what we know. We know the opposite side. We know the hypotenuse side. So of SOHCAHTOA, what are we going to get to use here? SOHCAHTOA. So here I know opposite and hypotenuse is the so. So we say sine of the angle equals the opposite side over the hypotenuse side. Now to get x by itself, what's attached to it? So I know there's a sign on here. So the way to get sine off of it isn't to add it, subtract it, multiply, or divide. We're going to take the inverse of sine on both sides. So we've got x equals the inverse of sine of 12 over 20. Let's go ahead and go back to your calc. Okay, we're going to clear this out. So we're going to go inverse sine. So that's going to be anything that's in blue, we have to hit the second key, and we're going to hit the sine key right there. So we're going to go inverse sine of 12 divided by 20. Okay, we see that here. Go ahead and hit enter. And we see it's 36.869. So that's approximately 36.87 degrees. Okay. All right, almost done. Given triangle DEF. So if we don't know what this triangle looks like, you're going to just draw your own based on what else we see. So angle E is a right angle. So I'm going to draw a right triangle where angle E is the right triangle, and it's triangle DEF. So I'm just going to name it DEF. You can name it however you want. You could have put D and F in those opposite spots, however you want to do it. But angle D is 62. So I know this is 62 degrees. And side E is 12. So if this is angle E, side E is opposite from it. So that's 12. Okay. And it says find F. So we're looking for little f. So if this is angle F, little f is right here across from it. So this is what we're looking for. So again, you are going to label from the angle that we have. Here's my opposite side. Here's my hypotenuse side. Here's my adjacent side. We are looking for F, and we know side, the hypotenuse. So what two sides deal with A and H? Well, SOHCAHTOA. I know SOHCAHTOA is, the ka is A and H. So we're going to use cosine of the angle equals the adjacent side of that side F that we're looking for over 12. So now we're going to solve for F. We're going to multiply both sides by 12. So 12 times the cosine of 62 equals F. Okay. Plug that straight into your calculator just like that. 12 times cosine of 62. And we get approximately 5.63. And again, this is not an angle, it's a side, so it's just a length. All right, angle of elevation, you've seen this before in geometry, but remember, angle of elevation always comes from the base and it goes up from the base. So the angle of elevation looks like this, okay? An airplane takes off with an angle of elevation of 12 degrees, so here's 12, and raises to an altitude of 1,500. So let's say here's your plane, okay? Don't make fun of my plane. I'm really bad at drawing, seriously. So here's my elevation and altitude of 1,500 feet. How far is the plane from the airport via ground? So here's the ground. So what we're looking for here is, what's this? Okay, so what do we know? Well, we're going to label this just like we did before. So here's my angle, here's my opposite side, here's my hypotenuse side because this is the right angle, and here's my adjacent side. I'm looking for the adjacent side, and I know the opposite. So in SOHCAHTOA, we're going to look to see what deals with the adjacent and the opposite. Adjacent and opposite are right here. So we're going to say T is tangent of the angle equals the opposite side over the adjacent side, which is X. And now we're going to solve for X. Because X is in the denominator, we have to multiply it out. We're still looking for X, so we're going to divide both sides by the tangent of 12. So we've got X equals 1,500 divided by the tangent of 12. Plug that into your calculator just like that. And we get approximately 7,056.95. And this is in feet because they do give us the units. All right, last part, angle of depression. So just like angle of elevation went from the base, angle of depression is from the top. Okay, so Mr. Brust looks out his window. So let's say here's the building, okay? Mr. Brust is looking out his window with an angle of depression. So that means Mr. Brust, his eyesight's right here. He's looking down. And he sees two kids fighting. So here's two kids fighting. Okay. He decides to break up the fight as long as it's less than 50 meters away. So Mr. Brust decides sometimes it's not worth it, right? So we need to figure out if it's less than 50 meters away and will he go break up that fight. So if his window is 28 meters from the ground, so his window right here is 28 meters from the ground. Let's see, will he break up the fight? So I need to know what this right here is. So I know that this is a right angle. We know that the angle of depression is 32 degrees. So from his line of sight, if he was looking out straight out his window, it'd be right here. But he's having to look down, so that's 32 degrees. That's his angle of depression. I also know this is 28, if you want to use that, or not 28 degrees, just 28 feet. Okay, so we can also say that this is x. So if I want to look at just this triangle right here, here's our angle. So this is our opposite side. Here's our hypotenuse. And here's our adjacent. We're looking for the adjacent side, and we know we have the opposite. So is it so, ka, or toa that we have to use here? Well, we're dealing with opposite and adjacent, so it's got to be toa. So tangent of the angle is 32 equals opposite over the adjacent. To solve for x, we're going to multiply it out of the denominator. Now to get x by itself, we're going to divide by the tangent of 32. So we get x equals 28 divided by the tangent of 32 degrees. Put that in your calculator just like that, and we get approximately 44.8 feet. So since the fight is less than 50 yards away, Mr. Best will go break up the fight. No more fighting, right? All right, guys, thank you so much. We'll see you back in class.